So this video is for Integrated 3, the Quadratic Web worksheet. I'm going to explain how to get the values for the table for 1 and 2. I'm not going to work all of them out. So if you're trying to do this table, you have the equation y is equal to x squared minus 2x minus 8. I am going to substitute in -3 into my x's. So -3 squared minus 2 times -3 minus 8. I'm going to work that out. And when I do, I'm going to get a 9, negative times negative, that's going to give me a positive 6 minus 8. So when I do that math, I'm going to go 9 minus 8, which is 1. 1 plus 1 is 7. So this is going to be -3 comma 7. I'm going to do that same thing to generate each of these numbers. Okay, so for example, if I put in a 4, okay, so you're going to do that for each of these numbers, but I put in a 4, I have 4 squared minus 2 times 4 minus 8. I get 16 minus 8 minus 8. 16 minus 8 is 8. 8 minus 8 is 0. So this would be 4 comma 0. You would then take those points and plot them. So you need to figure out the rest of these going through the same process, taking each number, putting them in for your x and working them. Same idea on number 2. Okay, then you're going to plot them here on the graph. Now, going down to these ones here, where it says write a possible equation for the given graph using the x-intercept. So when you are trying to write these, what we learned in Integrated 2 was everywhere that we have an x-intercept, it actually came from a factor. So if I have an x-intercept here at -1, and I have an x-intercept here at -3, I ended up getting my -3 from the factor x plus 3. I ended up getting my -1 as an x-intercept from the factor x plus 1. So that is one way you could write this. Now, we could also multiply this out. So if I was to multiply this out, I'm going to take x plus 3 times x plus 3, x plus 3 times x plus 1, and I'm going to get an x squared. I'm going to get a 3x. I'm going to get an x, and I'm going to get a 3. So you can also write this in standard form, x squared plus 4x plus 3. I would probably, for this one, write it in either of those two forms. So you're going to try to find the x-intercepts, okay? Those x-intercepts, wherever they are, so again, this one was at x equal -3. So my factor is going to be the opposite of that, x plus 3, because if I was to take that factor and set it equal to 0, whatever I get, that is going to make that equal 0. That is going to be where my x-intercept is. So that's going to be a -3. Again, this one here was from an x plus 1, because if my x plus 1 was set equal to 0, whatever makes that factor 0, that's going to be where my x-intercept is. So on number 4, you want to look and see where these two x-intercepts are. So you have one at x, and you have one, at x, at 1, at 0, I apologize, and you have one at 2. Now, the factor for the 2 came from x minus 2. So the factor x minus 2 gave me the x-intercept of 2. The factor that gave me the 0 is an x. So this equation would be y is equal to x times the quantity x minus 2. Or you can multiply it out. In this case, you would just distribute it and get an x squared minus 2x. Now, on a problem like number 5, we have two x-intercepts here again, one at -1, 1 at 4. So you're going to go y equal, you're going to give me something times something. You're going to look and figure out, well, what factor gave me the -1? What factor gave me the 4? And you're going to put them into these spots. Then you can multiply it out and put it in standard form like we did on number 3. Now on a problem, so I want you to try 5 without me giving you the answer. On number 6, first off, this is opening down. So that means I'm going to have a negative in front of my equation for my parabola. Also, I only have only one x-intercept, and that x-intercept is at +2. So what factor gave me a +2? The factor that gave me a +2 is an x - 2. Now, since this only crosses once and parabolas will always be a square, what's happening is I'm actually having that factor x - 2 twice. Okay, I have that twice because I need to get that squared. To get my parabola, it needs to have a square. So my equation is going to be y is equal to x - 2 squared, or you can multiply it out. Remember, that would be an x - 2 times an x - 2. If I do that math, either doing a box, or honestly on this one and this one here, if I was multiplying this out and I was trying to multiply x plus 3 and x plus 1, I would have multiplied them, gotten a 3, added them, gotten the 4. The sum is what your x is. The product is your constant. I probably would have worked it out that way if I'm going to be honest with you. On this one here, when I have an x - 2 and an x - 2, again, you could do -2, -2. That's going to multiply to a 4. It's going to add to a -4. So that's going to be an x squared minus 4x plus 4. So either of those would be acceptable. When you're looking at number 7, use the x-intercept and the vertex to sketch a graph. Okay, so for this one, they're not wanting us to make a table. They want us to find x-intercept. So when we are trying to find an x-intercept, I'm just going to use this graph here for a second. I'm just going to plot some points. This point here on the x-axis is 1, 0. This point here on the x-axis is 4, 0. This point here is 8, 0. If I'm on the other side, let's say go all the way over here, this is -10, 0. So what they all have in common is all of them have a y coordinate that is 0, because everywhere on this x-axis our y coordinate is going to be a 0 always. Okay, so the reason I'm bringing that up is when I'm trying to find an x-intercept, I really want to know what's going to make my y 0, because I need an output of 0. So I am going to take x squared plus 6x plus 8, set it equal to 0, and then we're going to factor, which is what we were working on at the beginning of the school year. And I really want to figure out what multiplies to 8 and adds to 6. That would be a 4 and a 2. So I am going to get as my factors x plus 4 times x plus 2. Now we want to solve this and we want to see what makes each of these parentheses 0. So I'm going to get x equal -4 and I'm going to get x equal -2. Those are my x-intercepts. So first off, I know that I can plot those. So I'm going to have, what is it, -4? And I'm going to have -2. Those are going to be my x-intercepts. Okay, -4 and -2. Now, halfway between every point on a parabola that is at the same height, you're going to have in the center where your vertex is going to be. It's always going to be halfway. So I know halfway between my -4 and my -2 on this line somewhere is going to be my vertex. So to find that halfway in between, really you can average your two x-intercepts, add them up, divide by 2. I'm going to get a -6/2, which is a -3. So I know my vertex is going to be on this line of x equal -3. So I know my x-coordinate of my vertex is going to be -3. I need to find my y-coordinate. So I'm going to go to the equation that they gave us, this equation right here. I'm going to use that equation, and I am going to substitute in my x, -3, just like I did for the table on the page before. So, oops, sorry. So I am going to go y equal -3 squared plus 6 times -3 plus 8. Again, I'm looking at this equation here. So that's going to give me that my y is going to be 9 minus 18 plus 8. Well, 9 minus 18 is a -9. -9 plus 8 is a -1. So my vertex is going to be at -3, -1. That is my vertex. Okay, so I'm going to go down to -3, -1, which is right here. Okay, I'm just going to get rid of that line. And this is going to be a sketch of my graph. I'll teach us how to more accurately graph it, but they're asking us for a sketch using the x-intercepts and the vertex. So on number 8, similar idea. We want to find the x-intercept. I'm going to put 0 in for my y to find my x-intercept. Now, a problem like this sometimes gives students trouble. I want to factor this. And when I'm looking at this, I'm really looking going, hey, there's an x in both terms. So I'm going to factor out an x, and I'm going to get an x times x plus 2. And then I'm going to take those, and I'm going to set those factors to 0. So I'm going to get x equals 0. Set this one to 0, I get x equal -2. Those are going to be my x-intercept. So I'm going to have 1 at 0. I'm going to have 1 at -2. Now, halfway in between those would be here. That's going to be at -1. But let's say I had a problem where I couldn't really tell because of the way the graph was. You can add your two x-intercepts together, divide by 2. Again, I'm averaging my x-intercepts. That's what I'm doing. And so I'm going to get -2/2, which is a -1. So my vertex is going to be -1 comma, and I need to find my y. And again, to find my y, I'm going to take this x, which is the x-coordinate of my vertex, and I'm going to substitute into that equation. So I'm going to do -1 squared plus 2 times -1. So it's going to be 1 minus 2, which is a -1. So my vertex is going to be at -1, -1, which is here. And then I can draw my graph. On a problem like number 9, okay, I'm going to have you guys try this one. But I'll set it up. You're going to put 0 here. You're going to have 2x squared minus 5x minus 3. For a problem like this, you're going to probably want to factor it using a box to diamond. You're going to put your 2x squared here. You're going to put your constant -3 here. Always with this setup, when we are having it in this way, when I multiply these together, that's going to give me what I put here. But I need it to add to that number here. So I need it to multiply 2 2x squared times negative 3 is a negative 6x squared. And we need it to add to this number here. So we need it to add to a negative 5x. So you want to try to figure out those and factor that problem. You're going to end up getting something times something from your factors. Take those factors, set them equal to 0, and find your x-intercept. And then average, just like I did on 7 and 8. This one's a little more trickier, but we've been practicing factoring. I know we can do it. And hopefully that helps you guys out, gives you a little reminder of some of the ideas we learned in integrated 2.